the world, perhaps all over the world, with a continuous increase of neurodevelopmental disorder, neuropsychiatric diseases, neurodegenerative diseases. We will see the data. Cancer. Cancer is not increasing in aged people, in adults. It is increasing in babies. It is increasing in children. This is very strange. We cannot explain this by the old traditional genetics. We are witnessing obesity everywhere, and diabetes too, and autoimmune diseases increasing everywhere. So, what is arriving to mankind, and what can we do? If it is genetics, we can do nothing. But if it is epigenetics, if we can find the way to change the destiny of next generation. So that's why I think it is important to speak about this. That's why it is 20 years then I try to explain to my colleagues, the pediatricians and neonatologists and oncologists and neuropsychiatric neuropsychiatricians, that we must do something to change the destiny of our next generations, and that the very first 1,000 days of our lives are much more important than the rest of life. Embryo, fetus, and the 2 first years of life. To change, there is something to change, or I must change from here? Okay, it goes. Well, I decided to begin with this paper. This was a very breakthrough paper on Lancet. You know, Lancet is the most important journal of medicine all over the world. A pediatrician and an epidemiologist 12 years ago began saying that perhaps we have a sort of silent pandemic of neurodevelopmental disorders due to thousands of molecules, pesticides and metals, benzene and hydrocarbons that are everywhere in the atmosphere of the cities, in the food chains, and they try to quantify the problem. The problem is this. This is autism cases in the last 20 years. They are increasing this way. You see better here, you can see the number of diagnostic every year increasing from 50,000 in 92 and 163,000 in USA 10 years after. And if you look at the difference between the increase in autism and the increase in all disabilities, you can understand that the brain, not the brain, the neural networks are the real target of this kind of pollution and of exposure to a lot of stressors. And you see that the increase is not gradual, it is really dramatic, and you can see the same increase in United Kingdom and in the United States. And if you look at the CDC of Atlanta data, you see that 30 years ago we had 1 child on 1,000 and 500,000, I cannot say it, you can read it. And now we have 1 child in 70. But this is an old data. These are old data, because 5 years ago it was valuable, but now we see that the situation is much worse. You see, in Great Britain we have 1 child in 59 with autism. In USA, 1 child in 59 1 year ago, 1 child in 40, this is pediatrics, 4 months ago. The increase is really dramatic, and it is not an increase of diagnostic. This is an increase which concerns really the way in which we are disturbing the neural networks of the children. Here we see that a lot of diseases that we have always considered separate disorders are the same problem, which means synaptogenesis and neural networks in the very first steps of life are disturbed by a lot of pollutants and stressors. And we can see that also, for example, mood disorders are increasing everywhere in the children. And we can see that 1 person to 9 in USA have this kind of diagnosis, depression major, which is and we see that also neural disorders, right, like multiple sclerosis, are increasing in the north of the world and only in the north of the world, not in the other countries. And we see that Alzheimer and neurodegenerative disease are a sort of epidemics everywhere. You know, they have told us it is the increase of age, you can understand even if I speak a bad English, okay? Okay. We see that that in USA we have 6 million people with Alzheimer now. In Great Britain, 1 and 3 million people. In Italy, it's the same. 50 years ago, in the autopsies, there was practically no one had Alzheimer. This is the reality. This is 50 years difference. So, how can they tell us? How can someone define all this as genetic? The risk of autism connected to unexpected exonic mutations. You know what that project, that genome project, was the biggest problem, the biggest project in the world in the last 30 years. Trillions of dollars. It has given us different answers from them that Big Pharma was waiting for. This is the reality, I think, that I have no time to explain all this, but you see, you can read everywhere, autistic children have 3 mutations. They continue to say that it is genetics. This is not genetics, it depends. They have forgotten, if you read in the journal, in the really scientific paper, damaging de novo mutations. This is the difference. You can read de novo mutations. De novo mutations are mutations that are not in the parents, but they are in the children, in the autistic children, and in the sperm of the father, for example. So there is something new. This is not genetics, not traditional genetics. There is not something that passes from a generation to another. This is not a sort of genetic, how can you say, a problem, a sort of damage. And for cancer, we will see that the same problem. Cancer is not a genetic accident. It's the product of a lot of mutation, but the mutation is the consequence of years of instability in the genome. This is quite different than considering all this as genetic accidents. So, how can we propose a sort of model to work together in the next years? I think that we can propose something like this. DNA has billions of years. The brain is the product of phylogeny. The brain is quite similar in everybody. DNA is quite the same in everybody. But then we have the epigenome, which is completely different in everybody, and we have a connectome, which means neural networks that are completely different in everybody. This is epigenetics, this is ontogeny, this is individuality. DNA is not individuality. The great part of the DNA is very similar in everybody. The brain is quite the same in everybody. So, what we mean epigenetics and genetics? An easy way to explain all this is the kingdom of genetics. The DNA is specific to the species, is a product of phylogeny. We see the hardware of DNA similar in everybody, and the brain, the Brodmann areas, and the ancestral wiring in the brain is quite the same in all the species. So it is quite useless to search inside in the DNA the faults that can explain diseases. And then we have the software. This is the epigenome, this is the connectome, this is completely different in everybody. This is the product of 2 years of programming. This is completely different in everybody. This is disturbed by a lot of pollutants and stressors and so on. This is the problem. The real problem is that we can make a lot if we can change the destiny of millions of children, not looking at DNA, but looking at the epigenome and at the very first step of life. In this model, you can see that the most of neurogenesis and of synaptogenesis, which mean about 86 billion neurons, occur in the first 700 days of life. This is the real important period of our life, the most important. There is, for example, some months ago on Nature Neuroscience, a very interesting paper was published demonstrating that in the very first part of life, the neurons are programming themselves, and the neural network are the product of this programming. So we must begin thinking that a lot of chronic diseases, not only neurodevelopmental disorders, not only neuropsychiatric diseases, but all the diseases that are increasing everywhere, also metabolic diseases, obesity and diabetes 2. Diabetes 2 was a disease of old people. Now it is a disease in USA of adolescents. So this is the programming which is disturbed. This is, you know, now in USA we have one person on 33% of persons who are obese. Obesity is not overweight. Obesity is an endocrinopathy, a chronic endocrinopathy, which has hypothalamus and hypophysis and the other glands and the muscles and so on that are completely wrong. They don't work correctly. There is a sort of chronic inflammation. So it is a very complex disease. So we have a really transition, a really change in epidemiology all over the world. All the chronic diseases, all the inflammatory diseases and cancer are increasing. These are the data about obesity. You see that the increase is in the children, the biggest increase. And you see the same in autism, you see the same in cancer. This is the biggest study, an epidemiological study in Europe. You see the maximum of increase of cancer is in the first years of life. 2% of every year of increase. And it is not leukemia, not common leukemia. It is neuroblastoma, rhabdomyosarcoma, lymphoma, and other kind of leukemias that are increasing in the first years of life, which means that it is not stochastic mutations. This is not something that increases during life. There is the fetus, this is the gametes of the parents that are disturbed in their programming. It's always the same problem. You see the increase in asthma, you see the increase in gluten sensitivity, you see perhaps we can have now a sort of unique model. The unique model is this one. It is the fetal programming which is disturbed. So we must look at these two words. What does it mean, fetal programming? Fetal programming is not a concept. Fetal programming is the way in which trillions of cells from the zygote to the fetus to the adult are epigenetically programmed in a correct or in a mismatched way during the very first step of life. So there are a lot of pollutants everywhere that pass through the placenta, metals and ultrafine particles and endocrine disruptors. Endocrine disruptors is a bad term because endocrine disruptors means that they are molecules that can change our endocrine systems. But in the fetus you have not an endocrine systems. In the fetus they are morphogens. They are molecules that can change the differentiations of cells. So they are mimetic molecules that can give bad information to the cells that are differentiating their epigenome. So you can understand the power of all these. You find in every placenta of the world 700 pollutants. We are looking for this now. I can show you what we are trying to do. Our hypothesis is that the great part of these chronic diseases, inflammatory and neoplastic and chronic and metabolic and neurodevelopmental, are the same problem. They are a programming that is disturbed in the very first step of life. With this institute this is the European Cancer and Environment Research Institute, in which I work. It is 10 years that I work with them. We have been invited in many countries in the world. This is Martinique. Martinique is a little island, it's a sort of paradise. But in Martinique you have the world record of prostate cancer. And you have a continuous increase of obesity, diabetes, and autism. So when in the last Congress in Martinique, I asked, can we suppose that the exposure of the fetus to something is disturbing the programming of the tissues? And can we suppose that a single molecule, which the name is chlordecone, is a pesticide, that France has utilized in Martinique for 30 years, and that is everywhere in all the food chains, can change the programming of the neural networks of the children, of a lot of tissues of the children? Can we suppose this? But anyway, you can understand that a lot of French epidemiologists were there to say that is not true, but last year demonstrated that prematurity is increasing in Martinique. This was very correct from that. So that's why I decided to show this study. They are French colleagues, and they have proposed that the prematurity is a bad sign of chlordecone invasion of the placenta. So we have asked the Italian government to study the placenta, because the placenta is not, we have always thrown away placentas as thinking that placenta is only an ephemeral organ. But it is a very important organ that the fetus produces to take information from the mother and to program itself, owing to, we can say, to balance, to program itself in an adaptive way, in a very predictive way, on the basis of the information coming from the mother. So we have asked the ministry, the health ministry in Italy, and we have received some money to study the placenta in Taranto. Taranto is the most polluted town of Italy. We are trying to collect placentas and to have mass spectrometry, immunohistochemistry, epigenetics, mitochondria, and metabolomics of this placenta to have biomarkers of exposure and risk to give to pediatricians. We will see if pediatricians will help us, because it is not so easy to convince pediatricians to work on this. They are not very competent, and they don't like to make this kind of work. We'll see. Well, all this is a theory now, developmental origin of health and diseases. This was the first Congress, the first World Congress about maternal and fetal origin of diseases in London, and I tried to demonstrate that these pandemics are the consequence of bad programming. This was this year the second Congress, and I tried to demonstrate that there is a transgenerational transmission of carcinogenic risk through the generations, and that the increase in cancer is epigenetic and not genetic. I cannot explain all this today, but the problem is to have a completely different model. This is the model, PIEPS. This is very, I try to simplify. It changes completely from genetics to epigenetics. If we consider the epigenome as a sort of systemic, complex, open to information coming from outside, that is completely changing every day in every cell, trying to adapt the genome to the new environment. And if the environment changes too quickly, the project is disturbed, the program is disturbed, the epigenome began to be unstable. So this instability in the very first step of life makes a bad programming in the fetus when the developmental plasticity of the organism is in the maximum step, and a lot of diseases that are increasing, perhaps, I say perhaps, but I am convinced that we can demonstrate this, are increasing everywhere owing to this mechanism, developmental origin of health and diseases. There is no change in our phenotype, pathological or physiological, that is not induced by the environment, conditioned by DNA, but modulated by epigenome, which means 100% DNA, 100% environment, 100% epigenome. This is not correct to say 20% DNA, 20% environment. No, it's 100% because they work together. It was a wrong idea to think how much is genetic, how much is every changes in our phenotype are genetic and epigenetic and environmentally induced. And if the environment changes completely every day, the fetus must program itself in a very different way every day. You understand the problem, which is a quantity of information and the quality, a completely different quality of information that is going to the fetus. All this was, in my life, in the life of other researchers, began 20 years ago with this beautiful article, a sort of breakthrough, in which Adam Wilkins began asking why physics has had its revolution with quantic physics and relativity, and biology cannot have its revolution. And Richard Stallman, some months after, on Nature Biotechnology, which is a very important journal, answers because we have dogmas in biology. For example, Darwinian dogma, for example, that mutations are stochastic and that selection decides and that the genome cannot change to adapt all the time. The Crick dogma, you know that Crick dogma, which means that DNA decides and RNA and proteins are the consequence. These are completely wrong, Stallman says. It's only a little piece of a great system. The genome is induced to change all the time. If you look at the genome, the genes are only 1%, perhaps 2% of the genome. The great part, 98% of the genome, is not proteins, is not producing proteins, is not coding DNA. And it is the most important part of the genome because it is changing all the time. It is a sort of ecosystems, open to the environment and changing itself. So the key is to consider the epigenome as the software changing all the time owing to the information coming from outside. The flux of the information is from outside to the genome, not from the DNA to the phenotype. So the phenotype is the product of a sort of computing and processing information coming from outside. This is completely different than the basis of the molecular reductionist way of considering genetics. The information coming from outside has the same importance that the information which is coded in the DNA from billions of years. And the most important moment of our life is this one. And if we look at this model, we can understand, because we have trillions of cells. All the cells come from the zygote. Every cell has the same DNA. Every cell is completely different from each other. You see the difference, for example, between the neuron and the lymphocyte. They have the same DNA, but they have a completely different epigenome because they have received completely different information. This is the power of the epigenome. This is the great difference, and we must look inside in the software, not in the DNA, to understand what is beginning to change the software of cells. If you look at the epigenome after 30 years in the twins, we see that the DNA has not changed, but the epigenome is completely different, and the two twins make completely different diseases. This is not the DNA that has changed, but the epigenome has changed all the time. So the genome can do natural genetic engineering. He was a genius. He is a genius. Jim Shapiro. I hope that next year we will invite him, because Jim Shapiro is really someone who has changed our way of considering the genome. He speaks about the capacity, the possibility, but even the necessity for DNA to have continuous changes in the epigenome, and that the changes in the epigenetic software change the DNA in a very intelligent way. This is the problem about consciousness all over in the world and in the cosmos. Intelligence is everywhere. So to consider the DNA as a molecule is not sufficient. To consider the genome as a system that changes itself in an intelligent way is something like Federico's model tries to understand. So if we must consider in this way the genome is a sort of system that changes continuously. The most important part of the genome is not the part that is coding the proteins, it is the software, it is the mobile sequences, it is the retrotransposons, it is the way in which the great part that produces microRNAs changes all the time their products on the basis of the information coming from outside. The mobilome, the great part of the genome, is much more important than the codifying DNA, the coding DNA. If we look at the cells, the two populations of cells that have the most different epigenome and the most different genome, even the sequences that change completely continuously, are the lymphocyte, who make VDJ recombination and somatic hypermutation and so on, and you find all the lymphocytes are different in their epigenome, and neurons. This was a really breakthrough article saying that in our brain neurons are completely different. Every neuron has 2,000 mutations, sequence mutation, DNA mutations that are not dangerous. You understand the difference? Because we can ask how many cancers are due in the brain to these mutations? No one. Because we are witnessing an increase of cancer in the brain, but not, these cancers are glioma, glioblastoma, astrocytoma and meningioma that come not from the neurons, and the neurons have a lot of mutations that are useful. And the mutations in the brain are in the frontal and prefrontal part of the brain, which means the most powerful part of our brain, which means that the genome changes in the brain continuously, adaptively. This is very interesting. This is a completely different way of considering the genome. The genome makes somatic brain mosaicism. You have 30 billions of neurons in your cortex. Every neuron is different from the other. Every neuron has his DNA. And if you look at the mechanism are double-strand break. We read in the great part of the books that DNA breaks, the double-strand breaks of DNA are accidents due, for example, to X-rays. This is not true. The double-strand breaks are the way in which the DNA changes itself all the time. This is natural genetic engineering. This is a very adaptive way of change completely and continuously the software and even the hardware in the brain. So if you look at, you have seen the data of the article by Adam Wilkins and Stroman, 1997. From this moment, if you look, if you put on PubMed the name epigenetics, you see this increase in studies. If you put cancer and epigenetics, 1997, you see this increase in studies. If you put autism, if you put brain, if you put, for example, the name microbiome, 1997. This is interesting. This is always the same data, because the microbiome, the ecosystem of microbes that we have everywhere in the system, in the tissues, but in the gut is the most powerful part of our ecosystem. These microbes can modulate epigenetically or the construction of our psycho-neuroimmune system. So that's why we are studying all these, and we find the changes in the microbiome in every chronic disease. So this is the software that is changing, and if you put on PubMed the name endocrine disruptors, you find the same increase, 1997. You see the increase of the studies. So we have two programs, not only DNA, but we have the epigenome, and we have the connectome. The DNA doesn't change in the centuries. And you see the consequences. The bad consequences are that we have a lot of people that have much power, that have the same DNA. This is the Sanger Institute. That's not my idea, but anyway. And when when Bush was the president of USA, the Sanger Institute has told we have lost 5 million years. You see the similarity between the third and the fourth chimpanzee. You see, that's the similarity. But when the fifth, the new president was elected, where is Robert? You have not I've seen that you have Obama now. You have not you decided not to have Trump here, perhaps. But anyway, when Trump was elected, we have lost 7, perhaps 8 million years. You see the similarity with the first one. This is really terrible. Not that is, but anyway, we must think that DNA is not all. We must think that perhaps something can change. And we must really understand that what is the difference in the disorder, in this kind of disorders, are not genetic, but epigenetics. A lot of increase are not the brain structures that are in danger. There is the software, the connectome, that is continuously changing, and so we can make the difference. The increase of the cases is continuous and alarming. The traditional genetic risk factors have not been found. The most important mutations are de novo in the parents' gametes and in the fetal development. They are not transmissible from a generation to another. So autism is a non-hereditary, not genetic, but epigenetic diseases. But if you look in the great part of the books and even in the papers, you find that autism is genetic and that schizophrenia is genetic. This is not true. This is untrue. It's not genetic. It is genomic. It is epigenetic. It is something, and we can do a lot if we make primary prevention, reduction of the exposure of the fetus, and perhaps, this is my prayer, perhaps meditation. I think that meditation for women in the period of pregnancy, for example, and a lot of take care in the very first step of life can change perhaps the risk that the connectome is not harmonic. So I think that we can do a lot of things, but we must not be no, you must say it loud because I cannot, not hypnotized by geneticians. I think that we must understand that when you are, for example, the twins share the placenta share the environment. That's why epidemiological studies must be revised and reconsidered. It's not genetic. The copy number variants that we find completely increasing in the autistic children are not in the parents. It is not the hardware which is in danger, it is the software, it is the connectome, it is the individual couplage. If we look at the chimpanzees, you remember the 5 primates, in their brain you find the same areas, that, for example, the Wernicke areas, the Broca area, are in the chimpanzee brain, but they cannot use them because they have not the connectome, they have not the neural networks useful. They cannot learn music. They can feel something when they hear music, but they cannot learn to make music or to speak. They can understand some words, but they cannot have a language like other because they have not the connectome, they have not the software. So the software is much more important. The software, the connectome, is completely different in everyone. It is the product of something that is in the very first 2 years of life. So this is the moment, this is the period of our life which is the most important. Cells migrate to find their places, and, for example, electromagnetic fields can change the trajectories. So perhaps I will not have time to show you, but we have some studies demonstrating that electromagnetic fields change the trajectories of the neurons that are migrating in the fetus. We have found it in the mice. I agree that mice are completely different from man, but the migration of the neurons is not so different in mice. So if we see that electromagnetic fields change the migration in the brain of the fetus in mice, I think that the same problem we have in children now. You see that in a child, when you see prematurity, what does it mean? That the child has not his brain, he has not, how do you say, the circonvoluzioni cerebrali. It's too difficult for me. But anyway.
Cortex. Convolution.
Yeah, okay, this one. Okay, and then you know, after the second year, when a child of 2 years had his connectome, which is practically finished, but he has too much synapses, too much, he begins his pruning, and the pruning is disturbed by a lot of chemicals and a lot of electromagnetic fields. So it is easy to understand why not only autism is increasing, but schizophrenia too, but depression too, because the pruning in the, you don't agree? No? You don't think that the pruning is very at risk in the adolescence, and that perhaps the way in which schizophrenia is produced?
No, I think.
Well, we will. Yeah, okay, it's interesting. I think that you don't agree with many passages, so it would be interesting to you know, in 1 hour, for me that cannot speak English, it's not so easy to make but anyway, what we can find, for example, is a different epigenome in every autistic child. We see the methylome, which is different. We can find, for example, the effect of the smoke of cigarette on many genes in a child, in a fetus and in a child. We can see a lot of epigenetics marks by alcohol. We can see a lot of different epigenetic marks in obesity, in maternal obesity, and the fetus can have the consequences, but we can see above all the consequence of the inflammation of the mother, which means cytokines that go to the brain that is programming itself, and we can see, which is perhaps much more important, that in autism and in schizophrenia we have an inflammation of the brain. We can see that a lot of pollutants that we find in placenta can pass to to the fetus, we can try to understand the windows of exposure in the fetus, and we see that dioxin and furans, polychlorobiphenyls are in the placenta, and they are very strong endocrine disruptors. We can see that pesticides are everywhere in the food chains, and pesticides have been constructed and conceived as neurotoxical drugs against insects, but they are neurotoxical for children too. So we can evaluate the risk of pesticide everywhere in the food chains. We can see that particulate is not the PM10 that we must consider. It is the ultrafine particles, which mean 0.1 micron. These can pass every barrier. The cerebral barrier, the placenta, the plasmatic membrane, the nucleus, and go to the epigenome and change it. So if we find that autism is increasing, is doubled in the great cities in USA, for example, Los Angeles, this is the double of the data that we have seen in CDC Atlanta. And we see the same in all the areas of the great cities. But what we see too is the ultrafine particles can pass through the nose and go to the frontal area and to the hippocampus. And in Mexico City, a study, which was really a dramatic study, you can find that the dogs in Mexico City have beta amyloid everywhere in the brain. So they have a sort of Alzheimer. It's different in the dogs, but it's similar. And some epidemiologists went to Mexico City, and they found that even young people in Mexico City are, when they die in for accident, for example, in 30 years old, they have amyloid everywhere in the brain. So the amyloid means that perhaps the metals and the ultrafine particles can change the way in which the beta amyloid folds. And the bed folding of the beta amyloid can produce the, I cannot say it in English, precipitation. No, I don't say it. Precipitation of beta amyloid in the frontal area and then in the hippocampus. And if you expose monkeys, little monkeys, when they are in embryo, to the atmosphere, to the air of Mexico City, you find that at 8 years they have already amyloid everywhere in the brain. So even Alzheimer's diseases is perhaps a fatal disease. It's a pediatrician disease. Do you understand this? Mm-hmm. I think that this is a very different way of considering. The last passage, electromagnetic fields and digital addiction. I cannot read, but perhaps you can read. Nomophobia, internet addiction, social media addictions, hyperbullying, hikikomori, which means that in Japan now more than 1 million adolescents don't go out from their rooms. This is a different way of considering pollution. This is not pollution. This is a new system, a new social system, a new cultural system. All these guys are not the consequence of the exposure to smartphone or digital system, but they are completely addicted to video games. They live inside. They don't speak with people. They are not interested. They are even not interested in Facebook and in the social networks. They live in the video games. This is the rapidity of the increasing of these technologies. This is the problem. It's the rapidity of the increase. And the system cannot adapt itself. And now we are waiting for this one. Nobody has made experiences, and it is not possible to make an experiment about 5G. We have asked, but it is very difficult to receive attention by the agency, but OMS, for example, WHO, for these problems, because the agency is not so, they cannot work on this. This is the truth. So we have decided to organize a site about, this is the site if you want to find there. We have conceived this site 10 years ago. Now we have thousands of papers about this kind of problems. We have this, for example, we have published this one last year, and we have received a lot of articles that were criticizing this. Not only one which was a real article written by scientists. There was a great part where articles written, but the difference is that when we write something like this, 1,000 people perhaps can read it. When they go on Times, they found millions of people that read that this is trash. This is the difficulty to publish now for us in the media. And this is the possibility that when we expose cells to electromagnetic fields of the same frequency of the smartphone, we see that after some minutes we have heat shock proteins and the instability in the genome. After 10 minutes, 7 minutes, 10 minutes, we see that the embryonic stem cells and the tissue stem cell are the more plastic and the more sensitive to the electromagnetic fields. We can show that in the rats, if you expose the fetus, you have a difference in you have an impairment of glutamatergic synapses. They are 80% of synapses in the brain of the mice, but anyway, in the children it's not very different. You can see that if you look at the exposure of a child and an adult, this is a difference. The difference is that if you expose a child, you have the great part of the brain which is exposed to the smartphone, and mothers don't understand, because in Italy we see that there are a lot of little children with a smartphone, 2 years old, 3 years old, and it is really dangerous. We have tried to demonstrate that not thermal effects of electromagnetic fields are much worse than the thermal effects. We have tried to show that the way in which they have considered the increase in cancer is not real, because the study, interphone study, which is this one, is between the exposed people that don't use, that have the smartphone, but it means nothing. If you try to divide populations and you put between the really exposed people that use the smartphone 1 or 2 hours every day, and it is already 10 or 15 years that they use the smartphone, you see that the increase of cerebral cancer is a reality. You can see the number. I cannot show it, but anyway, I leave you the slides so you can look at them. So we know that electromagnetic fields are of high frequency and low frequency, and many times we say perhaps radiation are dangerous if we have high frequency. It's not true. Low frequency are very dangerous for cells. For example, this kind of electromagnetic fields are very dangerous. We have demonstrated an increase of children leukemia near the electromagnetic fields due to electrodox. I don't know how you say in English. We have asked the IARC to consider, this was a letter that we have produced 10 years ago. We have asked to the Agency of European and Cancer Research, but to consider electromagnetic fields as probable carcinogenic. They have decided that they are possibly carcinogenic. It's completely different. Possibly carcinogenic is not probable carcinogenic. But they are reconsidering now the classification, and this is an article that one of us, Professor Levis, has produced, in which he demonstrates that if you looked at the studies, the studies that are industry funded haven't found an effect in 70% of cases. But the studies that are independently funded, they have found 70% bad effects. 5 minutes, yeah, but I finished. Only the psychological effect. You know that in the night, the great part of our children and adolescents, they don't sleep. You know that this kind of technology interferes with the production of melatonin. You know that they sleep at school afterwards. You know that anxiety and normophobia is increasing. This is a study we are, with Daniela, we have a great study now in Italy about the possibility to evaluate how many times one day a child touches his screen. It is about 2,500 every day. And if you, every time that they touch the screen, they don't use the telephone, they touch the screen, the dopamine is increasing. You know, this is the same circle of the addiction, every addiction, drugs, and so on. So can we say that a lot of children and adolescents in our countries are addicts? I think that this is a risk. If this is the real problem, we must tell mother that this is a risk. In Italy, the Society of Pediatricians have decided not to write, to put in a document all this, because we don't know, because the literature is not enough. The precautionary principle doesn't exist. But anyway, and in USA, they are trying to understand if there is a link between the increase of suicides and all this. I think that perhaps it's not so easy to make the difference between a lot of problems, but if you look at this figure, you can understand that we are foolish. You know what is granny? Granny is a criminal grandmother, which goes through the families, and the child must learn to kill her. It is the joke. This is everywhere in USA has a great success, and there are a lot of parents that are joking with their child. So, do you understand? I think that we must try to make something to avoid all this, because this is a really foolish way of acting. So the stress, for example, we know that the stress of the fetus is very dangerous. We know we have had a lot of studies to demonstrate that there are epigenetic marks in the fetus due to the stress in pregnancy. But what we know now, that is not only mice. We have a great study in USA demonstrating that a lot of people that got suicide have the same epigenetic marks than in the mice. And what we have seen also is that in the survivor of Auschwitz, not only the survivors, but even their children have a lot of visible and invisible mark in the genome. So there is something that can pass from a generation to another. And the same studies were done in Africa after some dramatic war. So to finish with some beautiful note and information. The stem cells in the milk of the mother can repair all this. Because they can pass in the brain of the children. The milk can really, the stem cells of the milk of the mother go through the barriers, go to the brain. They are changing it themselves in oligodendrocyte, in neurons, and can repair the damage. So I think that it is very important to know this, and I'm really finished saying that that's perhaps enough for today. I apologize for the bad news. I hope that we can try to speak about all this in a quiet way, because for me, running through the slides, it was very difficult, and for you perhaps too. I apologize. But I think that it is important to quote Max Planck, a new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because the opponents eventually die and the new generation grows up that is familiar with it.
Fantastico.
Ma tu stai con me però.
Sì, 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 sì. Hai preparato benissimo.
Abbiamo fatto un'ora.
So we have time for 2 quick questions.
And I hope that Matteo will stay with me to help me to answer, to understand the question.
Question,
Short,
1
5 minutes
sentence.
maximum.
Thank you for that. Thank you for that really interesting presentation. I'm not a scientist, so I find it.
Wait.